Hi, I'm Matt, and do you want any of these following features? Number one, do you want an inexpensive flight controller for your fixed wing models? Do you want stabilized modes which are going to help you enjoy FPV more? Maybe fly a fixed wing on a windy day, for example, not get blown all over the shop. Do you want a built-in on-screen display so that you can see what is happening with your aircraft? Do you want a brown switch, aka return to home just in case you get yourself into trouble? Maybe you want to do missions or some predefined flight paths or maybe some of the advanced stuff. And do you also want to be able to do this on the cheap as well, aka for about $45 USD? And also, do you want this to be in 100% plain English without a degree in nerd being required? Now, if you've said yes to one or probably all of those, then good news, you're in the right place. I'm Matt, and in this series, I'm going to be showing you how to set up iNav with some inexpensive kit. Literally, I just kind of spoiled the big thunder there a few moments ago. $45 worth of kit will give you all of those features and a bucket load more, and that's what we're going to be exploring in this series. Now, before we go any further, I want to explain why this series and why I'm sharing this with you, which is, in short, I fly some super fast models. For example, right next to me, I have the right wing mini Drac, and in here, now this isn't a cheap model by any stretch of the imagination, and inside, what you'll see there is an EagleTree Vector. Now, the EagleTree Vector is potentially one of the best flight controllers out there on the market, but it does come at a price, and quite a hefty price at that, for about $238 for a version 1 EagleTree Vector. And they are not cheap, but they are fantastic. They include all the features which I mentioned a few moments ago, a couple of others as well, built-in on-screen display, and crucially a GPS unit, and they will bring the model home. However, $238 is a lot of money for anybody. And that has what has inspired this hunt to find a cheaper option. And I've got some good news for you. I have been and found a cheaper option. It's called iNav, and that's what we're going to be exploring and setting up together during this series. Now, I do have a couple of slides up on the screen. These slides are mainly just for me to keep myself on topic. Now, talking about keeping ourselves on topic, let's move on to our second slide, which we've got here, and that's what we're going to be covering. So, an introduction to flight controllers. Before we go any further, we need to just get ourselves up to speed, if that makes sense. So, we're going to be looking at, and in this episode, so don't go anywhere, grab yourself a cuppa. We will be digging into these topics right now. So what is a flight controller? What features can they offer? The different types of flight controllers on the market in 2017, the different types of software and firmware, and also the differentiation between the two, the inexpensive route with iNav, and what you're going to learn in the rest of this series as well. Now, like I said, these slides are really just here to keep me on topic so that I can convey what can be quite nerdy information in plain English to you. So, moving on nice and quickly, what is a flight controller? Now, flight controllers are also short, you'll hear people call them FCs, flight controllers. They are the brain of the aircraft. Now, that doesn't matter whether it's a quadcopter or a fixed wing model. The flight controller is the brain of the actual device itself. Now, typically that brain is mounted on a little circuit board. Now, I do happen to have one here on my desk. It's not the best example, but I'm just going to pop that up on there so you can see. Hopefully that's come in focus. The big chip in the middle, that's actually an F3 flight controller, and that's it. It's just a processor chip mounted onto a board, and again, it doesn't matter. We'll be discussing some other devices in a few moments, but that's for all intents and purposes. A flight controller is a processor with some with some extra hardware around it, and some software and some firmware to support it to give you advanced features. In short, so Sometimes they come with protective cases. In fact, there's two there. There's a Pix Racer and there's a Pix Hawk. Those two are basically like the other board, but these have got little cases around the outside, and sometimes they don't. They will all typically have inbuilt sensors that detect orientation changes. So imagine that if you're on a quadcopter, for example, and by the way, this series is heavily focused upon fixed wing. Apologies, I don't fly quadcopters. So, and again, this is where my own personal desire for this finding inexpensive flight controllers, because I've tried the other devices and the best one is the EagleTree Vector, but it's just so expensive. And like I said, the good news is we've been and found a cheaper version. So anyway, coming back to the sensors, imagine you're on a flying wing and a bit of wind hits you on the wing like that. The flight controller's got sensors on there which will help you stabilize the aircraft back out, obviously depending upon the mode which you're in at that present in time. You may have just pass-through mode and you just get hit by the wing and you just cope with it on the sticks, or you could have another mode enabled and it will help level it out for you. Now, they can also, the flight controller boards, they can also receive user input. So in other words, from your transmitter, you've got the sticks in front of you. That will help you so that you can take your inputs, whether that be stick inputs or switch inputs, to maybe change the modes. Now, typically all of these flight controllers, well, definitely the flight controllers we're going to be discussing will require S-Bus or PPM output from your receiver. Now, I am going to make a few assumptions as we go along that you know what S-Bus is and PPM. If you don't know what it is, just check a couple of your receivers and see if they support that. Typically, it's just one set of wires coming out your receiver instead of separate channels for rudder, aileron, elevator, etc., etc. Now, we mentioned those basic sensors. Some of them have, well, they will all include gyroscopes and most likely an accelerometer as well. That's how they're able to work out which direction and what angle of attack and things like that they're on at the present moment in time in the aircraft. Now, some also may have other sensors like a barometer to identify the height of the aircraft, and some of them may also have a magnometer, which is the very posh word for a compass. So it knows which way is it pointing. So which way is north here? Actually, north is behind me, so I'm looking south at the moment. And if we had a little board in front of us which had a magnometer, aka compass, on it, we would know that we're looking south right now, which is great for GPS assisted modes, maybe a mission, for example. So you can go off to a predefined point and then fly a mission. Anyway, coming back, depending upon the firmware, now that's a key point, depending upon the firmware, the code which goes onto the device, GPS functions may also be supported. Now keep that in the back of your mind because that's an important point. Now moving on quickly, now what kind of features can these flight controllers offer you with additional software and firmware to support them? Because the chip itself doesn't know what to do, so we need to give it software and firmware on it so that it knows what the chip should do. Oops, should do. So here's a couple of features which they can offer you. Number one is stabilized flight control modes. So that is perfect for flying FPV or maybe helping train a new pilot. Geofencing may be a factor for you, so that you may be able to set a maximum height or distance away from yourself from where the model was launched, so the model is geofenced. Now obviously depends upon the software and firmware, but some of them offer it, some of them don't. You may like a loiter mode, so for example you found yourself a windmill and you want to loiter on the top of it. Or loiter mode for me generally means that, oh, what have I done with my drink? I'm just going to grab my drink-a-mo and have a quick sip. And because I've hit the model in loiter mode, it will maintain its height and then just circle until we knock it back out. Very handy mode. Waypoints, like me mentioned, create your own missions and then fly them. Maybe plot them out on a map. We want to go there, 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 and back again. Could be as simple as that. Maybe you would like an on-screen display so that you can see the current flight mode which you're in, your RSSI signal strength, the amount of current which you've used, your battery voltage, your heading, your speed, and so on, and your heights and other things which you would want to know. Well, if you're flying FPV, you kind of need to know about. And the last one is the last feature, which I'm going to make a point here. There are many others, but the big one for me is return to launch, or that may also be called as return to home. Now, you may hear those be called as RTL, which is return to launch, or RTH, which is return to home. They all mean the same thing. You click a switch, the model comes back to you. And I'll give you a heads up, I have only ever twice needed this mode. One of them was actually very recently, and the other one was about 6 months ago. And I take it from me, I fly an awful lot of FPV, so it's very rare that I need to hit the return to home switch. And when I have done, once with the EagleTree Vector, the model came home, and once with iNav, the model also came home as well. Now, obviously, that was in anger. I needed to hit, and again, it was obviously with a qualified spotter next to me, yeah, it was that, or the model was going in. You know, it was kind of clear cut. Obviously, I've been in hit return to home many times before, mainly because I've been bored. Maybe because I wanted to grab me drink from the side of me and then just enjoy the jolly on the way back home, or I've been testing. So just to put that into perspective. Now, there are many different types of flight controllers on the market. Now, I've got a couple of examples here, and again, I want to try and keep this example heavy and non-nerdy as well. So there are many off-the-shelf products which you can buy. Some of them work straight out of the box. Most need configuring, and whether while being installed or before it being installed. Now, the price points are correct as of May 2017, so they may go up or they may go down, and they're all in USD as well. So the first one is the EagleTree Vector, $238 per setup. I can tell you, I got 3 of them, and you might now understand why I've been looking for and why I'm super happy that I've been and found a cheaper alternative. EagleTree Vector, one of the best flight control boards out there, which offer all the cool features, but on the flip side, it is extremely expensive in comparison. I need to put this into perspective. The Pixhawk, I've got Pixhawk right here, literally pulled out of ironically, a 450 quadcopter, but that's a Pixhawk, quite a big lump. Yeah, and you'll see that I've got GPS hanging off the side as well. Really straightforward. They're about $77. Now, I have added $20 on top of the $57 price because you do need a GPS unit. Well, for the features which we're talking about, return to home, because the model needs to know where it is in space and height. The other option for that, following the Pixhawk strain down, is the Pix Racer, which is a slightly more expensive board. Again, $85 approximately with a GPS unit, which you do need to solder up and do a little bit of faffing with to get it to work. There's also other boards out there like the HK Pilot Mega. There's the I need to pronounce this one correctly, FY41AP. There's a light version for a bargain, $115, and there's also a full version for $207. There's also the NASA from DJI, which the only price which I could find this morning was $178, and there's also a bigger old BG something or other for $90, which I've never used one myself, but I only ever hear good things about the Bigelow device, mainly because of its ease of use. And it will give you just straightforward return to home. So if you just want straightforward return to home, no other cool features, then have a look at that option there. Okay, and again, we're following a specific route, but I'm trying to keep this as open and as honest as possible for you. Let's move on. I think it's a good point for us to get into the different types of software and firmware. Okay, now there is a difference between firmware and software. Okay, really simple, right? Firmware is what is stored permanently on a device. So a few moments ago, I showed you this little board, just like that board there. The processor, which is in the middle of that board, is a complete dumber, all right? It's got the IQ of 0. And the only way which you can get it to do stuff which you want it to do is by loading on firmware on there. And the difference between firmware and software is that it's loaded into read-only memory. So that means that when you, a simple version, again, and by the way, I'm keeping this as non-technical as I can, which is basically when you turn this device off, it remembers. So when you turn it back on the next time, it remembers all the settings which you had before. Okay, and then software is typically some desktop-based software, so some software which runs on your computer, and that's it. That's the basic difference. So we've got firmware, which basically sits on the device, and when you turn it off and turn it back on again, it remembers everything. And then software is the stuff which runs on your desktop, whether that be a Mac or a PC. Okay. Now it's also worth us bringing into this conversation different types of software. Now, if you're using PixHawk or PixRacer, now I am dumbing this down. There's loads of other boards which you use that can use the ArduPilot software. Then you're going to be either going to be using Mission Planner or Q Ground Control. Now, give you a little heads up, I've recently been using Q Ground Control, really like it. The setup process for that is absolutely fantastic. Now, that kind of ArduPilot or PX4, which are two different types of firmware which you load onto either a PixRacer or PixHawk there, okay? That's two types of firmware that with Mission Planner, and which is only applicable to Mission Planner or Q Ground Control. Out of the two, Q Ground Control isn't, just from my perspective, a lot easier to use. But there is one fatal flaw to the PixHawk and PixRacer boards, which is not because they're expensive, but they do require you to use an external OSD device, and that has been and probably will always be the biggest fundamental flaw to these devices, because typically you want an on-screen display and you have to wire that up separately, and to be brutally honest, I've had zero success. I can get close, but they're such a pain in the rear. And I'm sure those of you which have had great success with these will now go and leave a comment in the comment section underneath this video. Matt, I've had no issues at all setting up MWS OSD or Night Eagle's version. And that's great, that's nice for you, but to be brutally honest, none of it's really worked here for me. Won't switch modes. Quite annoying. Anyway, coming back to the topic. There's also other software. Maybe you're an old school quad pilot and you may remember Baseflight. Absolutely brilliant. That's what set the basis for what you may have heard of, which is CleanFlight. Now, before we get to CleanFlight, there was a fork of that called Baseflight Aeroplane, created by a chap called Patrick E, which did add GPS assisted modes to F1 flight control boards. So some of you may remember the NAS A32, and that's what you can run on a NAS A32. Now, if I've completely lost you there, don't worry. That's ironically, some slightly older boards and software which you could have been using previously. Now, bringing ourselves forward into the future, to getting close towards the present day, CleanFlight, I'm sure if you're a quad pilot, you've been in used or at least seen before. You may be using Betaflight. Now, Betaflight is actually based upon CleanFlight, so that's added. So it was a fork of that, and they've made it faster, etc., etc. Added new features like an on-screen display configurator for the newer boards and things like that. Now, the one fundamental flaw when it comes to CleanFlight and Betaflight is neither of them have any GPS assisted flight modes for quadcopters or fixed wing. It was basically, and again, this is going to be probably incorrect, but this is the way which I see it. Basically, they focused purely upon the quad flight modes, and the GPS features were just kind of like forgotten about. The same happened in LibrePilot as well, which is a software which I actually missed off the slide. And yeah, GPS features were just kind of forgotten about, with the big focus upon quadcopters, which generally didn't normally need GPS assisted features. Now, there is one little diamond in the rough here, and it's called iNav, and iNav is another fork to CleanFlight. So it's I need to get this correct. Basically, everything which was forgotten about for GPS assisted features in CleanFlight and then later on in Betaflight were then added in iNav. Now, iNav is a specific point of interest. We will be looking at that in much more detail later on, but for all intents and purposes right now, just be aware it's some desktop based software which works in Chrome, so it'll work on a Mac and a PC, and it's free. okay? But crucially, it allows you to load firmware on to your device and also control it remotely using a piece of software, and it will give you, or give us, all these different cool features. Right, 2 slides left, honest. Next one, the inexpensive route with iNav. Now this is the bit which has perked my attention. I'm sure it perked your attention as well. Keep in the back of your mind, you can have at least 5 setups of iNav with 2 inexpensive boards for the same cost of an EagleTree Vector and have pretty much exactly the same features. It's crazy. And I would like to make the point, it's reality. We saw the EagleTree Vector in the mini track a few moments ago. This is a Falcon, Skywalker Falcon wing, which I strongly suggest you don't buy because the lid just blows off and I've lost mine. But in the middle of there, we have a flight control board, and that setup cost me personally less than $45. And I've got all the features which we mentioned about previously: on-screen display, flight stabilization, a couple of different modes of that, and we've got the GPS stuck on the side so the model knows where it is, and it's some setup for FPV. So we've also got an OSD on-screen display also built in to the model as well. So let me just put that one down out of the way. So the inexpensive route using iNav. This is pretty cool because we can leverage what the quad pilots have been pushing over the past couple of years, which are faster processors, more components built on those tiny little boards. So all the work which they have been like pushing, we can now leverage as fixed wing pilots for our flying wings and our fixed wing models. This is a big one for me. I'm sure it's exactly the same for you. iNav runs on cheap quadcopter flight control boards. So these prices will probably go down, but let's put it into perspective. $25 USD for an F3 flight control board. So that's the board which sits in the model with the brain in it and a couple of pins hanging out the side of it. Like I said, I was going to keep this non-nerd, okay? We also need a GPS module. Now, I've got one here on my desk. It's actually attached to a Pixel, but that's completely irrelevant. There you go. That's an MAN. Put it on the web camera. There you go. That is a GPS module. It has a couple of wires hanging out at the bottom. I've just dumped that on my desk. They're really simple to wire up, okay? So, keep that in the back of your mind. For $45 and for 1/5 of the cost of an EagleTree Vector, I can have all of those features. Or for if again, personally speaking, for 1 Vector, I can have 5 of these setups. I don't know how many models you can see behind my head. I have quite a few, and I can assure you, I've bought at least 5 of these setups, and they are going in at least 5 of my models because there's such fantastic value for money. Now, this approach uses free open source software, which was bought from CleanFlight, which was iNav, which we were speaking about. Now, it does require some knowledge, okay? This is why I'm creating this series for you, is because you need some basic knowledge. And the only other thing which you need is some basic soldering skills. Some of those pins, and I still class this as being the most trickiest part of the whole thing, is blooming soldering on all those little pins onto the board, which I class as the tricky part. Not the setting up, not the plugging the stuff in the right place, not knowing what to buy. The hardest part of this series is going to be soldering the board. Keep that in the back of your mind, and I genuinely do mean that. That is the hardest part of this, okay? The rest of it I'll take you through and it'll be super straightforward. And the last part of this is that this approach has all of the major features which I would want. All the major features which you would want. Stabilized mode, keep your wing stable. An on-screen display, so when you've got the goggles on, you can see what your pack voltage is, you can see which direction you're flying, you can see your ground speed, your airspeed if you include an airspeed sensor, pack voltage, and so on and so forth. And crucially, the brown switch, you click the brown switch to get your model to come back home. This is very much the inexpensive route, and that's what we're going to be covering in this series. Now, the last part of this episode. And apologies, I've just seen the timer up there. It says 25 minutes. So if you've got this far, very well done. We're going to get into the practical stuff next. So what are you going to be learning in the rest of this series? Number one, the parts and the software you need and an overview to them. Literally, we'll take a look at the board. This is what you need. Go and buy it from here. Download this. It's going to be as simple as that. A working example. I'm going to show you an actual flight with a model. So let's just make the point here. It'll be probably with the Falcon wing, actually. We'll take that up for a quick jolly and we'll have a little fly around. Okay, so you can see what's going on. We'll have a quick talk over the features. I'll keep it as simple as I can for you. How to flash iNav onto your flight control board. That sounds really technical and really scary, doesn't it? Not really hard. You push down a button. Well, you download some software, 2 lots of software, which is free. You push a button on the board, you plug it into a USB slot, click a button, wait for it to find it, go to there, choose the right option, press load. It's not hard. Honestly, it's not hard at all. Just need to where to find the button. It's the hardest piece of it. I'm not kidding you either. Really straightforward. An introduction to the iNav configurator. So it's not scary for you, so you know what the different sections are. If you've been in use Clean Flight or Beta Flight before, it's going to look really, really familiar. So you're just going to make a point on this is what it looks like. Not hard. We'll show you then how to wire up your flight controller board along with GPS. So which pin do I jab this in? Simple as that. Straightforward as that. How do you wire it up? That's it. How to configure iNav for a flying wing. Now, I am a fixed wing pilot. I do have a couple of quads, but to be honest, my entire passion is with fixed wing models. In this series, I'll show you how to wire up iNav for a flying wing. Obviously, if you're using like a traditional fixed wing, which has one of those funny elevators and rudder doodads, is that you'll just need to adapt what I'm covering with you just for that. And again, it's really straightforward because there's a little diagram and it says, well, this goes to here, you know, really straightforward. How to install the board into your model along with the GPS unit. And the last point here is the really vague one, which is everything else, which I've forgotten to include in this slide. And that's it. So to quickly recap, iNav with inexpensive quadcopter flight controller boards. I can have 5 of those. You can have 5 of those with all the features which we've been discussed for the same price as an EagleTree Vector. And that's exactly the route which I'm going. And I'm guessing by now that's the route which you're also going to be following as well. So in the next episode, we will be looking at the parts and the software which you need and a very, very quick overview to them as well. So with that said, let's get moving. If you do have any questions, please just ask in the comments section underneath this video. Also, you might want to just have a scroll through the comments as well, because somebody else may have been asked the same question which you've got. And of course, maybe if you're a more experienced pilot with iNav, feel free to help out any of the newer users in the comments section below. So for myself, Matt, I'll see you in the next part. Cheerios!